Hello guys, Mr. G here, and we're going to continue with the test in organic or about organic chemistry. Last time we did question 1 and 2, which was mainly naming compounds and things like that. Now we're going to go to question 3, and this one will be related to physical properties. This question said 3 hydrocarbons, A, B, and C. Now note that all of them are hydrocarbons, okay? So that is important. Hydrocarbon, remember, only hydrogen and carbon. So just very quick recall, we are referring to alkanes or alkynes. Those are the hydrocarbons we're talking here about. With a molecular formula of C5H12, sorry. Now, which of the 3 we are talking about? This is the molecular formula of all of them. All of them have the same molecular formula. So all of them are from the same homology series. Okay? Now, what is this? This one will be related to, let's try to the alkane first. Is CnH2n plus 2. Let's see if this one fits. C5H2 times 5 is 10 plus 2 is 12. C5H12. So all of them are going to be alkanes. Right? So that is important to know here. We are dealing with alkanes in this question. So all of them are alkanes, guys, and that is an important thing. Are used to investigate the effect of branched chains. So what they change in branch change is going to be in this investigation the independent variable. So the branch chain is going to be the independent variable. They are changing the branch. So that is important. I don't know if they're going to ask anything about the variable, but I think it's important to notice. And the boiling point will be dependent. Right? So this is the question. The results obtained are given in the table below, and here you have the table below here. Remember, each of the compounds A, B, and C are alkanes. The 3 hydrocarbons are saturated. What it means but be saturated compound. Now, saturated, they're telling you here now, saturated compounds are the compounds that have only single bonds between carbon atoms. The word only here is an important word because there is only single bond between carbon atoms. This single bond is only between carbon atom. Is quite simple, okay? The alkenes and alkynes are to be unsaturated. One of the hydrocarbons, A, B, or C, has an unbranched change. Now you have to remember the relationship between surface area or length of the chain or mass and the boiling point. So the one that has the highest boiling point of the 3 hydrocarbons, which is this one here, will be unbranched. That is an important detail there. That one is going to be A. Why? Because it has the highest boiling point. Now write down the letter A, B, or C that represent this hydrocarbon. It's going to be A. Give a reason why the above mentioned compound are considered to be chain isomer. Now this have nothing to do with why this one is unbranched. I just explained, but which ones are, or why are they chain isomers? Because they all have same molecular formula but different chain. Note that all of these hydrocarbons there have the molecular formula given here on top, C5H12. The difference in the boiling point is because of the size of the carbon change, because the size of the compound. Explain why hydrocarbon C has the lowest boiling point. In the explanation, refer to the molecular structure of compounds, intermolecular forces, and energy required. So let's answer question 3.3 down here. Okay, the first thing you have to say is that compound C has a smaller surface area than compound A and B. Remember, you are comparing, so you must say that is smaller surface area than whatever you are comparing with. Now, you can also say here, there's many ways to say this one, guys. You can also say it has more substituents than compound A and B, it has more branch, it's more spherical, so on. But all that is referring to the surface area of the compound, so you are comparing the surface area here. So let's go to the next point that you must say, which is what is the relationship between that surface area and the strength of the intermolecular forces. So this will bring that the intermolecular forces are weaker. Now, important, we are referring specifically about the London forces. So I think you should mention the name of the intermolecular forces, which is London forces. So first you speak about surface area, then you speak about the strength of the intermolecular forces as you compare with the other one. Now, there is coming now the energy side. Now is the part where you say less energy needed to break, and guys, I want you to put attention about this one, to break the intermolecular forces, not the bonds. People attempt, or learners attempt to write bonds and they lose marks there. You are breaking intermolecular forces, no bonds. And this is it. The rest is obvious. You will have now the lowest boiling point in this case. That is question 3.3. It's quite simple, guys. Will the vapor pressure of the straight chain hydrocarbon, which means they're talking about the vapor pressure of this compound here. We're working now with A, which is the straight hydrocarbon. Mentioned in question 3.2 above the highest than or lowest than the vapor pressure of pentan 1 all. Now we are comparing a alkane with an alcohol. Okay, alcohol will always have stronger intermolecular forces. All right. Now the stronger, because alcohol, this is alcohol. Let's just write this one because it's like a recap as well. Alcohol will have hydrogen bonds, which is the stronger intermolecular forces of all. Now, the stronger the intermolecular forces, the higher the boiling point, the lower the vapor pressure. All right. So this one will have the hydrocarbon will have a weaker intermolecular force and therefore will have a higher vapor pressure. So we can go now and answer that question. So how are we going to do this one real fast here? We're going to start with the alkane. Alkanes have only London forces. That is important thing. Alkane only have London forces, guys. But alcohols, which in this case we're talking about pentan 1 all, has hydrogen bond. Have hydrogen bond. Now important, have hydrogen bond and London forces. Has hydrogen bond and London force. Now you come into the comparison. So this was the first point you have to mention. The comparison if hydrogen bond or the other way around. You can say hydrogen bond is stronger than London forces, or you can say London forces is weaker than hydrogen bond. We are comparing here, and that is an important point here. Hydrogen bond is stronger than London forces. Right? Other point is to say that the energy part here. So we say more energy needed. Now we are going to the energy needed to overcome, as just we said before. We are referring to the hydrogen bond, means intermolecular forces. You can say to overcome the intermolecular forces in the alcohol than the alkane, and so less vapor pressure. That is the final part of this question. And we are done with this question. It is not difficult. It's just a lot of thinking, perhaps, a lot of writing, but it's not that difficult. Let's go to the next question. Now, next question say bromine water can be used to distinguish between saturated and unsaturated compound. We just mentioned that before. Equal amount of hex2-in and hexane are added to respective test tube A and B at room temperature. 2 cm cubic of bromine water is added to each and the test tube shaken. The solution in test tube A becomes clear while the solution in test tube B has bromine brownish color. Alright? So what it means by unsaturated compound, and we already mentioned in the previous question what is saturated. So what is unsaturated compound? There are multiple bonds between the carbon atoms. We're going to answer here. There are multiple bonds between carbon atoms. That is unsaturated compound. Using structural formula, write down the equation for the reaction in test tube A. So let's go down. We need some space there to answer this question. Now, in the first test tube, maybe we must go back so you see. They say hex 2-in and hexane are added to test tubes A and B at room temperature. So A, that will have hex 2-in, and now hex 2-in. This is hex 2-in, and to hex 2-in you added bromine water or Br2. That is what you add there. So what is going to happen here? Well, the double bond here, that of the alkene, is going to break and give a space for the two bromine. So the two bromines will go in that specific space there, and then the rest is the hydrogens in the same way as they were before, guys. And this is the product that form. Now, what will the name of this product be? It's not a question, but it's a good practice. So it's going to be 2,3 dibromohexane. And this is the compound that is formed in this reaction. 4.3. Give a reason for the observation in test tube B. Now in test tube B, they say that while the solution in test tube B has brownish color, it means that the reaction did not actually happen. Now why did the reaction not happen? Because the conditions were not right. Not right. What conditions are we talking about, just to recall here? We need sunlight. We need sunlight to occur. We need low heat. We need sunlight for this reaction to occur. So maybe it was not on the sun. Now consider the diagram below. These ones are the tricky question because you have a flow chart, okay? And you have this one. Name type of reaction 1. What is the type of reaction 1? And we're going, something important, we are going from a double bond which is an alkene, let's write here alkene, to a haloalkane. Okay? So if you do that, what type of reaction you have there? From double bond to single bond, this one is addition. This one is addition. You add bromo, only one bromo is there, as you can see, you don't have dibromo. So this one in actual fact, it will be hydrohalogenation. But I prefer to write addition, at least they ask you for the specific addition. State the reaction condition required for reaction 2. Now reaction 2, they are telling you is hydration. So what are the conditions for hydration to occur? And I'm going to write them right here. You need for this one to occur, first of all, a catalyst. A catalyst in this case will be H2SO4. That is the first condition. The second condition, you need water, a lot of water. Lot of water. I write it in symbol, please write it in word. Lot of water. Those are the conditions for that specific reaction. State the reaction condition for reaction 3. We're almost done here. That is the substitution reaction where X is formed from 2-bromobutane. So now we are going to this reaction here. They're telling you substitution from 2-bromobutane. Alright, now what was going to be here? Here was an alcohol. The hydration of an alkene will give you alcohol, guys. So now you are going in reaction 3 from haloalkane to alcohols. And in that reaction, you need dilute solution of a strong base. So I am going to write it here down. So for this one to happen, you need dilute solution of strong base. Like for example, NaOH. This is just one example there, and you need mild heat. Those are the conditions you need for this reaction tree to happen. And then the final one, draw the structural formula of Y and give its IUPAC a name. Now, why here? We must be careful. We're coming from alcohol to Y. We're coming from an alcohol to compound Y, and we're going from 2-bromobutane to compound Y. Those are the two options to form compound Y. And in both cases is elimination. So we're starting, and remember also we're starting with the same compounds at the beginning here. We have this compound there. Now, if we go to this compound here, what are we going to have in the hydration? Let's go to the hydration quickly, real fast. We need that one. We have alkene with 6 carbons at the beginning. Sorry, with 4 carbons, not 6, 4 carbons here. An alkene with 4 carbons. So what we have is this one. We have 4 carbons there. The double bond is in the first carbon here. This is important because we need to know where is the alcohol, or how is the alcohol going to be, in order to see the alkene. So this is what we have. Make sure that is everyone have for now. From here to the alcohol, when you form the alcohol, the double bond break and the OH will take place there. Now you have 2 different places. Let's go there real fast here, because this one is the hydration you adding. Okay, so you open space. You have here 1 hydrogen as it was before, single bond everywhere, and then you have 2 different spaces here, 2 open spaces, 1 for hydrogen and 1 for OH. Remember, you adding H2O, that is the hydration. So this one will break into H and will break into OH. Now, which one will take the OH? The carbon that has less hydrogen will take the OH, and the carbon that have more hydrogens will take the H. This one is to form the major product. So this is the alcohol that we have here in compound X. Now, why am we doing this one? Because now we're eliminating. Now we are taking away the OH again. We give it, we're taking away. But we must take away OH and hydrogen. We cannot just take OH away. Okay, same happen in this case. You have 2-bromobutane. It's exactly the same, but with bromo. So what is going to happen here? Let's write it down here. And we are trying to deal with question 4.4. Okay, now we have this alcohol where this OH is going to be taken away. But it must be taken away a OH and the H as well. Which H will be taken away? You're going to take away the hydrogen from the carbon with least hydrogens. So from here you will get everything as it is, but those 2 ones are going to be away, they gone, and you will have a double bond here, as you can see there. So the rest is just hydrogen, guys. And we started in this reaction with 1 but 1 in, and we ending with but 2 in. This is the compound that is the down, which is compound Y. Draw the structural formula of compound Y and give the name. So the name of this one is but 2 in. And we are done with the test. I hope it helped, guys. Thank you for watching. I hope it really helped. You can suggest, you can ask questions. Mr. G here. I'll see you next time.